Hello everyone, and welcome to this video on comparing arrays to ArrayList. So at this point, hopefully you're familiar with both arrays and ArrayList, and if not, I would suggest you go follow through those lessons. So this is just going to bring up a lot of things we've already looked at, but in this case, we're comparing the two things so we can really see the pros and cons of each array or ArrayList. For the purposes of these examples, assume that on array, we have created an array, a string array, called A, and we'll initialize it with 5 elements, and assume that for ArrayList, I'm just going to make my pencil a little bit smaller here. For ArrayList, we have generated a string ArrayList. Oops. Got to give the variable a name. Also called A. We're just going to assume these are in different files so that I can call them both A, and then it leaves lots of room. Okay, so let's assume that for each of these we have declared and initialized an array or ArrayList, both of which would have the name A. Okay, so we're going to look at some different areas of comparison. The first area of comparison we're going to look at is the number of elements in an array. So when we're looking at an array, we are looking at a static or fixed number of elements. So when you initialize and declare that value, that's how big your array is. So if you declare it with 5, it is size 5 fixed. It will not be changing. And it's declared on initialization. Okay. For an ArrayList, on the other hand, we are looking at a dynamic list. So dynamic means it can grow or shrink. So it can change size as you add or remove elements. That's one of the key differences between an array and an ArrayList. Next, we're going to look at memory storage. So when we look at memory storage, we're looking specifically at how it's stored in memory. So for an array, I'm actually going to jump down to types it can store. So for types it can store, an array can store both primitive. So that's your int, double, float, Boolean, long int, etc. All those primitive data types. It can also store objects or references to objects. So in this case, it can store any sort of object that you create, and it stores references. And we'll look more what that means later. So it stores references to the objects. In the case of an ArrayList, it actually can't store primitive data types like ints, doubles, etc. It can only store object references. In order to overcome that, so that you can make an ArrayList of integers, what you end up having to do is use something called a wrapper class. This is just for if you want to use the integer, big I integer, double, Boolean, etc. And we'll look more at those wrapper classes, but you'll notice that in ArrayList, those are the only times you're using those values. You can't use this just set primitive types that we see. And part of the reason for this is how it's stored in memory. So when we look at how it's stored in memory, we are looking specifically at what it's storing. So for an array, when it stores primitive, it is actually storing the data types in order in memory. So stored in order. So that's where we get our like array, and the element at index 0 is 0 elements away from the array pointer, and it's actually storing the number there or the value there for the primitive data types. Then for non-primitive data types, so for objects, it's storing those references, as we said. So object references are stored in order. So the reference to the first element is stored in the first spot. The reference to the second element is stored in the second spot, etc. For the array list, it's literally just storing object references in order. Quick note about this, it's not actually storing everything in memory exactly like we think it would, because the CPU and modern day processors and modern day memory are all handled by your kernel or your operating system. And it's actually doing lots of things in the background to allow for multi-threading and efficient storage and all those sorts of algorithms. And because of that, it's more that when you're programming in Java, the kernel is creating the illusion to Java that things are stored in this way. And we consider them stored in that way in terms of efficiency and planning. But in reality, they're not necessarily stored exactly like that because of the way that technology has adapted and how we're making processors and storage faster and more efficient. We're doing that through some tricks, and those tricks don't necessarily relate to our model understanding of how we program. So that's an idea of arrays versus array lists in terms of the theoretical understanding of them. I'm going to make a separate video that goes through the actual code difference between the two.